In today's class, we will discuss experiment number 7 to experimentally find forces in various parts of a wall crane. The main purpose of this experiment is to see how the applied forces are distributed over the wall crane. There are many types of wall cranes which serve a separate purpose. It is basically a heavy machine which is equipped with some strong cables and pulleys in order to lift or lower materials or carry heavy objects to and from the site, construction site basically. So it is commonly used in the construction industry, and these images are showing different types of wall cranes doing different functions. In the first image you can see a mobile crane. In the second one you can see a loader crane which is carrying heavy load, and a tower crane which is also used in construction. In the last image you can see an overhead crane which you might have seen in the earthquake engineering center. This overhead crane is used to carry specimens or heavy models from one place to another within the lab. So for performing this experiment you will be needing weights, a wall crane and a measuring tape. This is how a wall crane looks like. The crane will be attached to a wall with a pin or hinge connection, and a spring balance is attached in the upper cable. You can see that the middle cable is attached to an adjustable connection which is passing from the pulley, and a hanger is suspended for hanging weights. On application of load in the hanger, some stretching will be caused in the middle cable, and this is the tensile force in this cable, which is equal in magnitude but opposite in direction to the applied force. Similarly, some tension will also be experienced in the upper cable due to stretching, and you can read the magnitude from reading the spring balance. Because of stretching caused in the upper two cables, you can also experience some compression caused in the lower cable, which is unknown and you have yet to find. Now, since the upper cables are experiencing tensile forces and the lower one is experiencing compression, we can call the upper two cables as tie members and the lower one as a strut member. In order to proceed with the experiment, firstly you have to label all the members and connections properly. Then you have to measure the lengths of members of the wall crane. You have to read the initial readings of the spring balance before the application of load. Make sure load is not applied yet. After you apply load, you have to observe the forces in the members and read the spring balance reading again after getting it loaded. Lastly, you have to draw a space diagram, and from the space diagram you have to obtain a free body diagram of O, which is basically the point of concurrency. You have to use the law of polygon of forces in order to find forces in all the members of the wall crane. Since we're talking about a system which is concurrent force system and a coplanar force system, we will be using law of polygon of forces in order to obtain the graphical solution and find the unknowns. So we already got through all the steps, and now we have to observe each step with illustration. This is how you're going to denote all the members and connections. You have to give them names. Then you have to read the spring balance before applying load, and will give you an initial value of tension which is denoted by Ti. Then you have to measure the length of all the members before loading using a measuring tape or a ruler. After the application of load at point D, and by placing weights in this hanger pan, you have to note down the reading of the spring balance again, and it will give you a final reading which is denoted by Tf. First you got the initial reading named Ti, and then you got Tf. You have to subtract both the initial and final values to get a net value of tension, which is basically tension in member 1. Then you have to observe the forces in the system. Let's see how the forces are arranged. We have a weight W hanging from point D because you have attached weights to the pan. We have a stretching force which is tensile force in member 3 passing from point C. We have another tensile force passing through member 1, point A. And we have a last force which is called the compression force passing through member 2. These are the forces, as you can see. Just measure the lengths of OA, OB, OC, AB and CB using a ruler. Lastly, you have to draw the space diagram from the measurements you just took. You have to take a suitable scale and convert all the actual lengths of the members to scaled length and also adjust the space diagram to your sheet. Scaling is really important. This is how scaling is done. Take a suitable scale and just draw the space diagram. Once you get the space diagram, you have to obtain a free body diagram considering this point of concurrency. These are how the forces are arranged. You have 3 forces, 2 tension forces and 1 compressive force. Now considering this space diagram, you have to obtain a free body diagram. This is how the free body diagram looks like. Since the system is a coplanar or concurrent force system, we will be using law of polygon of forces to obtain the graphical solution as I mentioned earlier. These are the knowns and unknowns. You have the magnitude and direction of W. You have the magnitude and direction of T2, which is equal to the applied force W. You have direction of T1 and C, but you don't have the magnitudes. You don't have the magnitudes of T1 and you don't have the magnitudes of C. So basically C and T1 is unknown. Using the graphical solution, you will be easily obtaining both of these magnitudes. Now let's have a look at how a polygon is formed. You have to simply place all the forces using the head to tail rule and form a polygon. Now you must have been observing that why is C not touching T1. C is short, so basically you just extend it a bit and you get a closed loop. This is how the polygon is closed. Now just take a measuring tape or a ruler and measure all these lines. Since you had used units of length, all these values will be in length. But from this diagram you can also obtain a force diagram, and when you use this technique to obtain a force diagram, you will get all the units in pounds. So they will be your forces. You got all the forces, you get the experimental values from your experiment, and the graphical solution will be obtained by constructing a polygon and measuring all the values. And after you measure the values, you have to convert all the units of length to units of force. Those will be your force values. So that's how you get T1, T2 and C. This ends your experiment and I hope you get benefit from this explanation.